All right, let's get started. It is September 19th, 2024, and you are at a special presentation with Dr. David Wiley at the University of Regina. Before we get started, I'd like to provide a land acknowledgement. I would first like to acknowledge that I'm here today on the traditional territories of the Nehewak, Anishinaabeg, Dakota, Lakota, and Nakota peoples and the homeland of the Métis Nation. I find myself extremely fortunate to live, work, and raise my children on these lands. I've been reflecting lately, and over the years, I've learned from the generosity and insights of Indigenous teachers and students. It has only been recently that I've come to fully appreciate how their influence has shaped my views on knowledge as something to be shared and nurtured, much like the land itself. This understanding has guided my approach to open education, which at its core seeks to embrace sharing and reciprocity. As we turn today to today's discussion on open education, I offer this acknowledgement with deep respect and a commitment to continue listening and fostering practices to honor these values. I want to first acknowledge, before we get into the presentation, acknowledge our staff. I'd like to recognize Shauna Neeson, the CTL's Open Education and Publishing Manager, who's developed and organized a stellar series of OER-related workshops, including this one. Shauna has done an incredible job supporting open education initiatives across the University of Regina. I'd also like to acknowledge the technical support of Syed Musavi, who's helped with a great deal with the technical aspects of this presentation, including the YouTube stream and just setting everything up and getting over our registration problem, which we ended up having a limit of 500 people, but something like 800 people ended up connecting. We will have the chat on today. We'll also have a Q&A. We may not get to the Q&A today. David's mentioned that if you do have questions, you could put them in the Q&A, and if we don't get to them today, he may be able to answer them on his blog. So that was very generous of him as well. So a bit of an introduction to our speaker. Our speaker today is none other than Dr. David Wiley. David is already known to many of you, and we've already included a full bio on the registration page. So in the interest of time, I'll spare you some of the detail. While David is currently the Chief Academic Officer of Lumen Learning, I know him as one of the most important and early thinkers and doers in the open education movement. I've been highly influenced by his work as far back as the 90s. He's cited in my dissertation. I've used his work hundreds of times in presentations over the years, and his work has been highly influential for so many of us in this room. Today's presentation, Why Open Education Will Become Generative AI Education, certainly a provocative title. It's created tremendous interest, as witnessed by the nearly 800 registrations for today's session. As well, the topic has certainly produced some pushback. For instance, if you haven't had a chance, take a look at the blog post from Heather Ross from the University of Saskatchewan and the rebuttal from Stephen Downs. Important points were made by each of these perspectives, and for me, as I read these posts, it felt a little like the early blogosphere debates of the 2000s. The only thing that was missing to me felt like I just needed Google Reader to make the experience complete. David has always had a knack of getting people to debate on these topics, and I'm certain that today will be no different. So with great anticipation and admiration, I will now turn it over to Dr. David Wiley. Over to you, David.
Thank you, Alec. Thanks so much. Thanks for the invitation. This is a super fun topic. These are questions I've been asking myself and struggling with for a while now. And to Alec's point about the early blogosphere, these ways of writing and blogging and putting ideas out into the world, and the feedback and the criticism or the reinforcement that comes back from that is just so valuable. So I'm so grateful that so many folks are interested in this topic, and really looking forward through reviewing the chat and the Q&A and other things. And hopefully there will be additional blog posts written after this to hearing more about your perspective and what you think about where this is all going. A quick overview. I want to start with origins and the goals of the modern open education movement, by which I don't mean like the open university, open education movement in the UK from several decades ago. I mean the open education movement that we associate with open educational resources. Talk a little bit about this idea of the most powerful emerging technology, and use that as a frame to get into talking about the impact of generative AI on traditional OER, the emergence of what I'm calling generative OER, how that might encourage us to extend and adapt our pedagogies, address a couple of objections and criticisms. I think it's very interesting that the objections and criticisms of generative AI are very similar to the objections and criticisms of OER 25 years ago. And then I'll wrap up with some concluding thoughts. So first, talking about goals, strategies, and tactics. For over 25 years, for me, I know everyone kind of came into the movement at a different time and in a different way. For me, I date myself back here to 1998, being when I started working, kind of really dedicating a lot of focus and energy to open education. But for over 25 years, I believe the primary goal has been increasing access to educational opportunity. Educational opportunity is made up of several things. It's access to other people to talk to and argue with. It's access to an instructor. It's access to a lot of different things, but the open education movement's primary strategy for increasing access to educational opportunity has been increasing access to educational materials. That has been the strategy, and the specific tactic that we've been implementing for over a quarter of a century now is creating and sharing OER. So let me tell just a little bit of my personal story, how I came into this. Again, I recognize everybody comes into it in their own way, but just sharing a little bit of my story so that you get some of the background and understand where I'm coming from. In 1998, I was working as the webmaster at Marshall University, which is my alma mater here in West Virginia. And I remember at that time having this epiphany. And it wasn't something that I was the first person to understand. Many other people had already realized this. Economists even had names for it. But I remember as I was sitting in my office doing my own work, having this realization that there's something very different about a physical resource and a digital resource. And with a physical resource, if my wife is sitting across the table from me at breakfast reading the physical newspaper, I can't read the newspaper until she's done with it and lets me have it. So there's some sense in which we have to compete for access to this physical resource. However, if you take that same news and instead of publishing it in print, if you publish it in a digital format online, 1 million people can all view it and access it and use it at the same time. And to me, this seemed like an incredibly important thing for me to understand and filled me with a sense of responsibility and obligation to take this realization and try to do something with it, particularly in the context of education, educational materials, and educational opportunity. Just because it's possible for you to convert a resource into a digital form and share it online so that millions of people can use it all at the same time does not make it legal for you to do that. And those of you who are old enough will remember Napster and LimeWire and other tools like that people used to convert physical resources they had, music CDs, into digital files, which they then shared, leveraging all the technical power of the internet in a way that was technically very compelling, but definitely illegal. So just because sharing was possible technologically didn't mean that it was legal. Now, our good friend, the Berne Convention here, and I say good friend in the most sarcastic way possible, enters into the picture here, because not only can you not share things that belong to other people, obviously, if other people hold the copyrights, you can't go online and share them without their permission. But the Berne Convention, as countries around the world signed on to the Berne Convention, copyright law changed so that instead of, if you had a work that you thought you might want to commercialize at some point in the future, you might want to protect it in some way, you would go and register for your copyright. As nations became signatories to Berne, copyright law changed so that the very moment a creative work was fixed in a tangible form, it was copyrighted to the full extent of the law. Whether you had any intention of ever commercializing it or not, whether you wanted that copyright protection or not, even if you adamantly did not want that copyright protection, it's still attached automatically to your works the moment they were fixed in a tangible form. So you have this incredible technical capability of the internet, making it possible to share. And yet everything that we create is copyrighted to the fullest extent of the law the moment it's created, whether we want that or not. And so in 98, I was reading on Slashdot, which was the place where we all hung out at the time, all the nerds and geeks back in the day, reading about what was happening with the free software movement, the open source software movement. And it occurred to me that maybe we could do the same thing with educational materials. Maybe we could take an open source style license, which makes it legal for people to download the source code, make changes to it, adapt it, use it in whatever way they want to use it. Maybe we could apply that same approach to educational materials. And so in 1998, I launched the Open Content Project, which included the first open license for educational materials and other kinds of content that aren't software. So that happened in 98. In 1999, I collaborated with Eric Raymond, who's the author of The Cathedral and the Bazaar, which is an incredibly important paper. I think everyone in our movement should read that paper, on the open publication license. Shortly after that, the FSF released the GNU Free Documentation License, or the GFDL. And then in 2002, the Creative Commons licenses were first released. And as the Creative Commons licenses became increasingly popular, we deprecated the OCL, we deprecated the OPL, and finally, kind of the last throes of these alternative open licenses for non-software creative works. It all kind of ended in 2009 when Wikipedia finally switched from the GFDL to the Creative Commons Attribution Share Alike license. But the point of all of this work around open licenses for content was that then what the internet made possible from a technical perspective was made legal, right? I could take my own resource and I could put it online and share it, and in a very easy way, let you know that you had permission to engage in what we would now call the 5R activities. So what the internet made possible, open licenses made legal. And 26 years later now, from 1998, huge progress in terms of improving access to educational opportunity, right? Over 2.5 billion works have been licensed under a CC license. I recognize that a large number of those aren't educational materials. And just sharing numbers that I know because they're from my work, like Lumen's OER have generated over 1 billion page views, and over 2 million students have been assigned our OER courseware as their required course materials. And then you think about the impact of all the other individuals and organizations that create and share OER. 26 years later, we've made some progress. This quote from the Open Syllabus Project here says, in 2013, OER textbooks were barely on the scene in US higher ed, used in only about 1 in 400 classes. 10 years later, it was 1 in 80. And Canadian OER adoption looks very similar, both in terms of rate of growth and its heavy focus on textbooks. So we're making some progress. I think the thing that's interesting about where the OER movement started, this idea of applying open licenses to content, giving people permission to engage in the 5R activities, all happened in the context of what was the most powerful emerging technology of its time, right? What we would probably call the information age. At this point, the most powerful emerging technology, which was the internet, could instantaneously make and transmit copies of educational resources at essentially no cost, anywhere around the world that there was an internet connection. And in that context, the tactic of creating educational materials, openly licensing them, and then sharing them as OER so that they could be made and so that copies could be made and distributed freely and legally around the world, that was the optimal way to increase access to educational resources. That was the most powerful technology. This was the way that we could utilize its affordances kind of most effectively to try to meet our goal. But what I want to suggest to you today is that we're beginning to transition from an information age where the most powerful emerging resource was about making copies and transmitting those copies around, into a generative age, which is a time when the most powerful emerging technology can create new resources on demand. And these newly created resources can be ordered to spec. You can say, I need it on this topic. I'd like these specific kinds of examples, use this specific kind of pedagogy, create this kind of practice along with it, with this kind of feedback. I want it in this language, etc. So thinking about it in kind of a fun way. If you're not familiar with the Drake equation, this is a fun kind of thought exercise. Thinking about what are the number of civilizations out there in the Milky Way with which we might be able to communicate, extraterrestrial civilizations. And the Drake equation is kind of a funnel, a funneling down or a winnowing down. You start with the average rate of star formation in the galaxy. Then you think about the fraction of those stars that have planets, the fractions of those planets that could potentially support life, the fraction of those planets that actually do develop life, right? You see how this kind of winnows down until finally you get to some number. And this isn't meant to be like an exact scientific formula. Obviously, there's tons of estimating going on all throughout here. But it's just a way of thinking about the way that things have to filter down before you reach the point of being able to estimate how many civilizations out there could we potentially talk to. I think there's something similar to the Drake equation with OER. When you need an open educational resource on a specific topic, you have a very kind of Drake equation-like funnel that you have to run through. First, you have to hope that someone else, somewhere else, has already created the resource that you need. Then you have to hope that they've openly licensed it. Then you have to hope that they've either published it online where Google can find it, or they've put it in a repository and created sufficient metadata for it. Then you have to hope that Google actually did index it, or that you're able to find your way to the specific repository where it's stored. And then you hope that all of your searching effort actually results in you locating that resource. So there's definitely the same kind of funneling, winnowing down. When you need a resource on a specific topic for a specific group of learners, you do have to run this kind of Drake equation sort of gamut. Whereas with generative AI, when you need an educational resource on a specific topic for a specific group of learners, you describe what you need, and then generative AI creates it. You're not hoping that someone else created it, hoping that they openly license it, running that whole gamut. There's something very powerful about living in a time, and granted, these capabilities are very immature today, but they're improving all the time. But living in a time when we can ask for resources on the topics we need, for the students we need, et cetera, and have them created essentially in real time. Now, there's a saying that's famous in entrepreneurship schools that you should fall in love with your problem and not your solution. Let me give an example of what it means to fall in love with your problem, not your solution. Say your problem is, I need a way to keep food, drinks, and other items cold. At one point, the solution to this problem was to harvest ice from frozen lakes and deliver that ice to customers' homes. Then there were some technological advances that happened, and a better solution was to make ice industrially, to make it close to where you needed it, and then from there, deliver it to customers' homes. And then there are additional technological advances that made it so that we didn't have to have ice delivered to us at all. We could make our own ice in our own homes. And kind of famously, the people who harvested ice from frozen lakes did not make the transition into industrial ice making. And the people who did industrial ice making did not successfully transition into the business of in-home refrigeration and freezers. The people who had focused on these previous solutions were not in love with their problem. They were in love with their solution. And as new technology came along and their solution became outdated, because they didn't see that actually we're in the business of helping people keep food, drinks, and other items cold, they thought they were in the business of harvesting ice and delivering it to people's homes. They weren't able to survive through that technological transition. So if you fall in love with your problem, you can always leverage new technology to solve your problem more effectively and efficiently. If you know that you're in the business of keeping food, drinks, and other items cold, then it makes complete sense for you to stop making ice and delivering it to people's homes and instead now get into the business of in-home refrigerators and freezers. But if you don't fall in love with your problem, if you fall in love with your solution, then eventually you'll be left behind. So if the problem that we care about in the open education community is inequitable access to educational opportunity, if that's our problem, and our primary goal has been what I've said, and the strategy has been what I've said, generative AI has the potential to provide access to dramatically more resources on more topics, in more languages, in more formats than the current kind of create each OER by hand through a bespoke process does. And if that's true, then the optimal tactic, or what we might call the best current solution for accomplishing the primary goal of the open education movement, is now generative AI. And a group of people whose primary goal is to increase access to educational opportunities by increasing access to educational materials, I believe really should begin shifting their primary focus from thinking about OER to thinking about generative AI. Now, OER will still have a role to play in the future, just like printed textbooks will continue to have some role to play into the future, but that role is going to decrease over time, I believe. So let's talk for a minute about the impact of generative AI on OER. When I say traditional OER, I'm going to contrast that with what I'm going to call generative OER in a minute. But by traditional OER, I mean this very common definition, the Hewlett Foundation definition, Creative Commons definition, et cetera, that OER are teaching, learning, and research materials that either reside in the public domain or have been released under an open license that permits their free use and repurposing by others. So we would typically think of these as being articles, chapters, textbooks, images, videos, audio recordings, simulations, et cetera, et cetera. Now, generative AI profoundly affects the way that traditional OER can be authored and the ways that they can be revised and remixed. And I want to talk about that for just a minute. And maybe set up this kind of before and after. Of before generative AI, all OER were handcrafted. But now with generative AI, they can be AI drafted. And generative AI can reduce the amount of time and resources it takes you to get to your first draft by an order of magnitude, by which I mean take the amount of time you used to spend, divide it by 10, and that's probably still more time than it's going to take you to arrive at a draft in the handcrafted model compared to in the AI drafted model. And we certainly see this in our own work at Lumen and other folks working in instructional design that I talk to at companies, at nonprofits, at universities. If you work in the business as an instructional designer, whether you're at a for-profit or a nonprofit, if you create educational resources for a living, you're probably already using generative AI, and it is reducing the amount of time it takes you to make that first draft by an order of magnitude. Now, philanthropists and others who want to be effective stewards of funding, I think are going to see that this is true. And I think they'll likely begin requiring new OER that is funded under grants to be AI drafted. Because all other things being equal, after that first draft, the OER should still go through a QA process, a peer review process, an editorial process. Like, it's just a first draft, right? But all other things being equal, why would you pay 10 times the amount to get to that first draft than you could if people were using an AI drafted approach to that first draft as opposed to a handcrafted approach to getting there? I think there's some interesting questions around stewardship of public funds or philanthropy to be asked there. And revising and remixing traditional OER, I think there are big implications here from generative AI as well. Again, open licenses make it legal to revise and remix educational materials, but open licenses do not give you the skills and expertise that you need to engage in maybe some high demand revise and remix activities like translating a resource into another language. A CC BY license might give you permission to translate that textbook into Spanish, but if you don't speak Spanish, it doesn't help you. Or it might give you permission to turn that static resource into an interactive resource, but if you don't know how to do that, permission doesn't help you. Or adjusting the reading level of a text from college to high school, or simplifying it for English as a second language learners. An open license gives you permission to do that, but if you don't know how, you're not going to be able. And this reminds me of Berlin's two concepts of liberty, if you're familiar with this. I think this is kind of popular in the OER space, but just in case, he talks about negative liberty and positive liberty, where negative liberty is freedom from interference by others, the absence of obstacles, barriers, or constraints. So there's nothing stopping me from doing what I want to do. I'm not being prevented. That's negative liberty. Because positive liberty is not just about the obstacles being removed, but it's about you having the capacity and the ability to act, to be able to do the things that you want to do, to make your own choices and achieve your own potential. So it seems like there is an interesting point to be made here about OER, generative AI, and the two liberties, right? Because as I said a minute ago, open licensing removes those obstacles and barriers to action that are created by copyright law. Or in other words, open licenses increase our negative liberty with regard to OER. But open licenses do not magically endow us with the skills and expertise that we need to be able to take advantage of those opportunities. So open licenses leave us still with a deficit of positive liberty. But generative AI gives us access to those skills and expertise, which increases our positive liberty with regard to OER. So if you think about time and effort as obstacles to revising and remixing, we published a paper over a decade ago showing that the more time and effort are required to engage in a specific revise and remix activity, the less often users will engage in it. So for example, users are far more likely to delete a chapter from an open textbook, which might involve, hitting highlight and hitting a delete button or something very, very simple, very quick like that. Far more likely to engage in a very easy and quick revise and remix activity like that than they are to write a new chapter or to make extensive revisions to an existing chapter. But inasmuch as generative AI makes these kinds of tasks faster and easier, I think now, in the context of generative AI, we should expect to see more revising and remixing happening in the future. Because as the revising and remixing gets easier and faster, more people should be likely to engage in it. So that's one. And a second point is around the quality of revise and remix. So if you're a follower of Ethan Mollick on Twitter or on LinkedIn or wherever you might be following him, he is fond of highlighting research that shows that productivity gains associated with using generative AI are the highest among lower skilled workers. And if you think about that, that makes sense. Now, for example, for a translation task, generative AI is going to be a lot more helpful to somebody who doesn't speak the second language than it is to someone who does speak the second language. If I don't speak the language that the resource needs to be translated into, I can't even get started. So it's dramatically more helpful to me than it is to someone who speaks the second language, right? So inasmuch as generative AI makes these tasks possible that were either previously impossible or impractical, we ought to expect to see an increase both in the variety, the kinds of revising and remixing that will happen in the future, as well as an increase in the quality of the revising and remixing that happens in the future. And I think those are all positive things. Pivoting for a moment from traditional OER to what I'm going to call generative OER. Generative OER are not designed to be used by teachers or students directly for teaching, learning, or research. They're designed specifically to be used as part of a generative AI system to create other OER. And the two things that I think are the most interesting for us to think about here are openly licensed prompts and openly licensed model weights. So let me take a drink here for a second. And let's talk about each of these and how they interact with the 5 R's and some of the other things that we've been talking about. Open prompts. Many of the prompts that are written by first-time users of generative AI are relatively simple. Something like, write me a poem about rainy days. All right? But when you really get into the work of trying to prompt these systems to do things that are more going to be more powerful or more effective pedagogically, you're trying to elicit more complex behavior. A prompt like that can be hundreds of words long or thousands of words long. And once you're into writing thousands of words, guess who shows up? Our old nemesis, Burn. And now we're back in the place where these more useful prompts are all automatically copyrighted to the fullest extent of the law the moment they're written. Which means if we want to be able to share prompts with each other and permit each other to revise them and remix them, it's going to require open licensing of prompts. Openly licensing prompts matters for a couple of reasons. First, I think there's broad awareness within the open education community that we need to be able to localize OER for linguistic reasons, to make them more culturally appropriate, for a whole host of reasons. I can't possibly, sitting here in my home office in West Virginia, anticipate every need that you and your learners who are somewhere else are going to have. And so when I put OER out into the world, part of why I put it out into the world under an open license is it's so that you can take it and make the changes that you need to make to it so that it will actually work for you and the learners that you're working with, whether it's you individually as a learner or you as a teacher working with learners or you're part of a group. There are changes that are going to need to be made, and you need to have permission to be able to make them. Users of generative AI are going to choose to use different generative AI models for a range of reasons. Maybe my campus has a subscription to Microsoft Copilot, or maybe we have a deal with OpenAI so that everyone has access to ChatGPT, or maybe I'm an independent learner and I can only use the free tiers of some of those, or maybe I'm using an open model on my own laptop for economic reasons, or because I care about privacy, or the point is that different users will choose to use different models for a whole range of reasons. And different models will respond differently to the same prompt, right? So another kind of critically important aspect of localizing prompts is being able to refine a prompt so that it will work with your model. Because it was probably, given all the models that are out there, it was probably designed to work with some other model, and you're going to need to do some work to it to make it work for you. Prompts are fairly straightforward. They look a lot like traditional OER. They're a bunch of words. Open weights, I think, are more interesting and potentially more powerful, certainly more powerful. And so I want to linger here a minute longer than we did on open prompts. Now, just say right at the beginning, I'm purposefully skipping over all the debate about what constitutes an open model. OSI is looking into that. There are lots of people arguing about that. We're not going to go there in this conversation. I just want to talk about open weights. Okay, so in a generative AI model, weights are, now this may not be a helpful comparison to you, and I apologize, but the weights in a generative AI model are conceptually similar to the weights that you calculate when you do a linear regression. A weight is a number, like that number there on the screen. And when we say the model weights, what we mean is we mean the dozens or hundreds of matrices that are storing the millions or billions of these numbers within them. Right? This is the heart of a generative AI model, is this collection of weights, which is a bunch of numbers organized into matrices that correspond to the different layers of the model. So when I say open weights, what I mean are these weights, these numbers in all their matrices, all of them, all the matrices, all the numbers that comprise the model, those being licensed in a way that we can retain, revise, remix, reuse, and redistribute them. And there are many models, there are many, I should say, there are many projects that have released their model weights under open licenses. This isn't like pie in the sky, this is already happening today. But it's not on the radar of a lot of people in our community, which is part of what I'm hoping to accomplish by talking a little bit about it today. Why would open weights matter? And let's linger here a little longer than we lingered on the conversation about prompts as well. Foundation models, those models that have been through the pre-training process, maybe haven't had any fine-tuning at all, like the instruct fine-tuning. Even if they've had the instruct fine-tuning, these foundation models like Claude's Sonnet 3.5 or a GPT 4.0 or even an 0.1, like as was released recently, they are not designed to behave pedagogically. Most often they're designed to try to make you happy, to try to follow your instructions and give answers to your instructions, or to follow your instructions in a way that's going to satisfy you. That's what they're primarily designed to do, at least the ones that we interact with. They're not designed to behave pedagogically. And they can lack disciplinary knowledge, they can lack cultural knowledge, they can lack a whole range of information that's necessary for a specific teaching or learning situation. Now, with prompting, you can temporarily change a model's behavior just for that session during which you're interacting with it. Or with a technique like RAG, retrieval augmented generation, you can temporarily change a model's behavior or change what it knows. But if you want to permanently change the way a model behaves or what it knows, you have to fine-tune it. And fine-tuning means changing the values of the model weights. Okay? And we'll talk about a couple of things. We'll talk about distillation and quantization, and other model changes are necessary if we want to be able to run models on consumer hardware, like our own laptops or our own phones. And I think that is critically important for a range of reasons too, which we'll get into. So fine-tuning is like remixing. If you think about the 5 R's applied to open weights, fine-tuning is remixing, right? And fine-tuning is a process by which you update, you change the values of those numbers. You update the model weights through additional training on curated data, and you've curated that data specifically for the purpose of changing the model's behavior in a specific way. So for example, if you're to fine-tune an open weights model, and your fine-tuning data included 10,000 examples of interactions between students and expert tutors, then after the fine-tuning process was over, that model would behave more like an expert tutor than it had before. Okay? And you can imagine that when you're trying to update millions or billions of these parameters, that is very computationally expensive, takes a lot of time, takes a lot of resource, takes a lot of money. So there are techniques like LoRa that make it possible to fine-tune only a subset of the model weights, instead of having to update, the 405 billion parameters in the Llama 3.1 model, so that it becomes possible for people like you and me, with the hardware that we have access to actually do fine-tuning. It's not just in the realm of Google and Facebook and whoever else. But fine-tuning is what remix means in the context of open weights, right? And distillation is a specific kind of fine-tuning, which I think is very interesting for our purposes. Distillation is a process by which you update the weights of a small model. So for example, in the recent Llama 3.1 release from Meta, there's an 8 billion parameter model, a 70 billion parameter model, and a 405 billion parameter model. Obviously, you're not going to run that 405 billion parameter model on your laptop, but you can run a version of that 8 billion parameter model on your laptop. It doesn't have all of the capabilities of the larger model, but this distillation process is a process by which you can update the weights of a smaller model using data that you've curated, but this time you're generating the data with the larger model so that you can transfer some of the knowledge and capability from the larger model into the smaller model. So now this fine-tuned smaller model won't have, the same kind of general purpose capabilities that the larger model has. But say you just want to create a smaller model, you just want to fine-tune this small model so that it's amazing at giving feedback on drafts of student writing. That kind of capability you could transfer from a larger model to a smaller model through this distillation process. And again, smaller models are faster because they're smaller and they're less expensive to run and might be capable of running on consumer hardware, like the hardware that you and I have. I also want to talk about quantization for a minute. Quantization it's more complicated than this, but conceptually it's similar to rounding, right? So say that in one cell in one of the matrices in your model, you have a dot, 0.42563, some value. If you were to round that off, say to 0.43, then you reduce the precision of the model a little bit, but you make the model size significantly smaller. Right? If each of the numbers stored in each of those matrices, if you've got 405 billion parameters and each of them are 16 characters long, and you truncate them to be 8 characters long, you've cut the memory footprint of the model in half. Right? Meaning that it's going to be faster and less expensive to download because it's significantly smaller now than it was before. And because it's smaller, again, I might be able to run it on my consumer hardware. Now, quantization is not rounding, just to be clear. I'm saying it's conceptually similar to that. The process is more convoluted, but it ends up with a higher precision number being a lower precision number, which is smaller and has these effects. So coming back to why open weights matter. With permission to engage in the 5R activities, we can use a range, these techniques I've talked about and others. We can use a range of techniques to change the way that models behave, to change what they know, to decrease their memory footprint, and do other things to them so that they can run on your laptop and eventually on your smartphone. And we've talked about revise and we've talked about remix, but retain and reuse and redistribute are also very important here. This permission to download and run smaller, customized open weights models locally, I believe, is going to be a key to our being able to use generative AI to improve equity and access in a way similar to MIT OCW's Mirror Site program does. So if you're not familiar with MIT OCW Mirror Sites, there are a couple hundred of them, 250, 300 something. And what MIT does is they take the entire OpenCourseWare site, copy it onto a hard drive, and they put that hard drive in the mail and send it to you. Because maybe where you are, maybe you have a LAN, maybe you've got a local area network, you've got Wi-Fi inside your school building, but your school isn't connected to the broader internet. So I can't actually use MIT OCW in this example because I'm not connected to the internet, even though the computers inside my building are connected to each other. But if MIT OCW puts the whole OpenCourseWare collection on a hard drive and sends it to me, I can plug it into one of the servers in the school, and now everybody in the school can access all of MIT OCW. When it's possible to download and locally run these smaller models, we'll be able to send them to the same kinds of places that we can currently send these kind of static resources like PDFs or websites or things like that, so that even access to the broader internet won't be a requirement to be able to use them, but you'll be able to use them in these offline settings like the Mirror Site program makes possible. And customizing those models and being able to run them locally does a bunch of things. It improves privacy because your conversation is never leaving your own laptop. It decreases energy consumption because the model is smaller, takes less energy to run, and now you're running it on your laptop instead of accessing some giant cloud where that's happening. And if the models are customized in ways that are informed by evidence-based teaching and learning practices, then we can increase the likelihood of improving learning outcomes through these customized models as well. And all of this is only possible if we have permission to engage in these 5R activities with regard to the weights. So open weights really matter. If you want to dip your toe in here and play around with running models locally, I've got the names of several projects here on the slide that will let you do that. I think LM Studio is kind of easiest to use, but your mileage may vary. One of the things I like best about LM Studio is that when you open it on your machine and go and start browsing through all the open weights models that are available, it will tell you, I don't think this one's going to fit on your laptop. Don't bother downloading it because it's not going to run. But this one looks like it will run. Go ahead and download it and run it locally. And just to be clear, when I say run it locally, I mean after you've downloaded it and you've started it up in LM Studio, you can turn off the Wi-Fi and use this generative AI system right on your own machine without any internet connection. Right, that's what we mean by running it locally. Okay. Two more topics, and both of them are shorter than the ones that we've just been through, so I'm hoping that we'll be able to get through them. First, I'm going to talk about impacts on our pedagogies. If you've heard me talk in the past, you've probably heard me talk about what I call OER-enabled pedagogy. OER-enabled pedagogy are the things you can do with OER that you can't do otherwise. The teaching and learning practices that are possible when you have the 5R permissions that are not possible when you don't have the 5R permissions, right? So for example, if you're using OER as a core instructional resource, you and your students might collaborate to revise and remix and then republish your course materials, both as an exercise in improving their own understanding, but also to better support the students that will come along next semester. Obviously, you cannot do that with a traditionally copyrighted resource. That's a kind of pedagogy of revise and remix that you can only engage in when you have the 5R permissions. I'm sure there will be something similar, although I think there's still a lot of exploring of the frontier yet to be done here. But I think there's definitely something analogous to OER-enabled pedagogy that we might call Gen AI-enabled pedagogy, which is the things you can do with generative AI that you can't do otherwise. So for example, when you're teaching a fully asynchronous online course where you never meet face-to-face, we're typically not able to assign synchronous collaborative activities like a think, pair, share kind of activity in that setting because the students are never together. The reason they signed up for asynchronous online was because they have crazy hours and crazy schedules and all these demands, and they can only do what they can do when they can do it. But if generative AI can play the role of that partner or that collaborator, or as Vygotsky might call it, that more capable other, then you can assign students to engage in some of these activities, even in this context, which you couldn't do before. Now, that's kind of a trivial case, but I hope that one example makes the point that when we can assume that students have access to generative AI, and if they're taking a fully online, fully asynchronous course, they're obviously connected to the internet. If they have access to a tool like that, now there are pedagogies that we can employ that we couldn't employ before. So what does that mean, and what will that look like? I think there's a lot left to explore there. I'm a big fan of this framing of thinking about barriers and removing barriers, that kind of negative liberty perspective that we talked about a minute ago. And I would suggest that, 30 years ago, let's say, the internet really removed time and place as barriers to education. Right now, you can do it from anywhere, you can do it at midnight, et cetera, et cetera. How did our pedagogy evolve in response to those affordances that the internet presented to us? OER removes copyright restrictions as barriers. How has our pedagogy evolved to take advantage of that affordance? Generative AI removes access to expertise as a barrier to education. How is our pedagogy going to evolve in that way? And when I say access to expertise, as an example, I mean, if I'm doing my homework at midnight, I have a question, I can't proceed until I get my question answered. Prior to generative AI, I would just be stuck. There's probably nobody else online, nobody I feel comfortable calling. My faculty members certainly not available for me to talk to get unstuck so that I can keep moving forward. But in the context of generative AI, I can have a conversation. I can ask a question. I can say that explanation didn't make sense to me. Can you give me another explanation? Actually, can you give me another? And use Taylor Swift as an example somehow, please. That kind of expertise in being able to answer questions, create new examples, create new explanations, give feedback. That's a big barrier removed. How will our pedagogy evolve? Objections and criticisms. And I said, I think it's so interesting to me, having lived through this the first time, to see it just playing out again right before our eyes. The number one concern about OER has always been, quote, quality. And so I've been asked all of these questions 10,000 times probably. If anyone can create OER, how do we know that they're going to be accurate? Are the authors experts? Do they teach at a prestigious university? Who does the peer review? What does quality control look like? And then the gotcha. See, I found an error on this page. You can't trust OER. Told you there are going to be quality problems. This whole thing is a scam. And the second concern has always been sustainability, right? Where is the money going to magically come from to pay people to create new OER? Once OER are created, when there's a new advance in the field, who's going to update it? When the information gets out of date, who's going to update it? When somebody finds an error, who's going to update it? And why should I go? I mean, if you've taught at the university level, why should I go to all the trouble of re-prepping my course from these materials I'm currently using that are working fine for me to start using this OER when there's no guarantee that it's ever going to be updated? And 2 years from now, 3 years from now, I'm going to have to re-prep my course again. And of course, if everyone starts using OER, does that mean that no one's ever going to get paid to write textbooks? What are we doing to authors' livelihoods? Are we destroying, authoring as a way of making a living? If you think about generative AI, the concerns are so similar. The number one concern is quality. If we don't know exactly what data the model was trained on, how do we know if its results will be accurate? If we don't fully understand the process of inference by which a model generates responses, how can we know its results will be accurate? Aha, see, look, it hallucinated. It made a mistake right there. I told you can't trust generative AI. This whole thing's a scam. And again, with generative AI, another concern that comes very quickly behind hallucinations and accuracy is sustainability. If generative AI is used to automate a lot of work, do I still have a job? Model training, both training and inference is what we call it after you submit a prompt and the model generates a response for you. That process is called inference. Training and inference require a lot of electricity and a lot of water. Don't models perpetuate bias? Isn't the way that human labor is involved in this whole process problematic? What do deep fakes and automatically generated misinformation mean for democracy? is this whole enterprise even sustainable? Right. So I want to give you a framework, or I want to suggest to you, feel free to wad it up and throw it in the garbage. I want to suggest to you, though, a framework for thinking about these objections. First, that generative AI right now is a lot like OER was in 2000. And when the very first open licenses were out there, Creative Commons wasn't even a thing yet. And a handful of us were stomping around trying to convince people to openly license their educational materials. People were somewhere between dismissive and just completely incredulous. At that time, we could see that there were promising pathways to addressing the real issues that people had concern about, and we'd already started doing the work. And we knew that it would never be perfect, but that it would eventually be good enough, right? That's where generative AI is today, from my perspective. Most people are somewhere between, well, I don't think anybody is dismissive anymore, but I think a lot of people are incredulous. But they might not realize that there are promising paths to addressing issues. Work's already underway. It's never going to be perfect. But arguably now, for many use cases, it's already good enough. And even now, 26 years later, if we're being completely honest, we still don't have great answers for the OER objections, but lots of people use OER enthusiastically anyway. So what I mean is when someone raises a concern about the accuracy or the quality or the sustainability of OER, an idealized response to those concerns would be to say, let's just take OpenStax for an example. They get huge grants. They spend as much as $1 million per book. The authors are experts from famous universities. They have a whole production process that mimics a big publisher process where the experts get support in technical writing and graphic design and editorial and copyright review. And there's a quality control and a peer review process that mimics the ones that the big publishers use. And in terms of sustainability, OpenStax generates licensing fees from their commercial partners, and they sell printed books, and all of that revenue means that they'll always be able to update their materials and keep them up to date. Now, if there are 1 million OER in this world, this response speaks to 50 of them, right? If you were to draw an OER out of a hat and respond to these concerns, a more typical response would be, well, an individual instructor applied for an OER grant at their institution and got $3,000. Then they wrote an entire textbook in 1 semester. They never received any production support, though we did give them a Pressbook account. And there was no peer review process, and there's no ongoing funding to update the resource after this semester-long grant is over. But that's actually what the majority of OER in the world look like and how they work. And yet we're all still very enthusiastic about OER and using them pretty effectively. Right. I see we're just about out of time. Let me share my concluding thoughts. If we're truly in love with our problem, which is inequitable access to educational opportunity, and we're not just obsessed with our solution, then shifting our focus from traditional OER to generative OER seems like the obvious path forward. Generative OER are capable of dramatically improving access to different resources on different topics with different examples and different formats and different languages, etc. And because generative OER can be interactive in a way that traditional OER cannot, they have the capability to improve the effectiveness of those opportunities once students get access to those opportunities. I want to acknowledge the change from working with traditional OER and a WYSIWYG tool like Pressbooks to trying to work with open prompts, and particularly with open model weights, is pretty similar to the change from working with HTML and CSS to working with JavaScript and APIs. Like, on the one hand, there are WYSIWYG tools, and like pretty much anybody can do it with minimal training. Working with generative OER, particularly with open weights, it's more technical and it's more complicated. I'm just acknowledging that. But it will also be significantly more powerful, in the same way that websites that have databases behind them, etc., are significantly more capable, useful, helpful than websites that are just flat HTML and CSS files. Final slide. Call to action. So after all these years, 26 years later, I am still dedicated to this goal of increasing access to educational opportunity. I believe that many of you are as well. I've also become interested in increasing the effectiveness of those opportunities, but that's kind of a separate conversation. But I'm still committed to this first goal. And emotionally, it's very hard to leave behind or think about beginning to move on from this traditional OER tactic that has consumed 26 years of my professional life. But I think that it's really important for the people that we're doing this work for that we use the best, most effective tools at our disposal as we do the work. So my call to action to you is, let's use the best, most effective tools at our disposal as we do this important work. And I know I've taken us 2 minutes past. I apologize, but thank you very much.
Well, thank you so much. I'm not sure if I'm on camera there or if you can hear me. I want to thank you so much, David, for your presentation. It was provocative, informative. There was a fantastic chat. There was some pushback, of course. I invite people to save the chat if they want to see, because there are plenty of resources that have been put in there. David's also said that he may look at some of the Q&A questions posted and potentially blog them. So you may take a look at that as well. We'll make the video available if that's okay with David. And I'm assuming your slides will also be made available somewhere as well, perhaps on your blog. Thanks so much, David. This was wonderful. And I really want to thank everyone for coming out on this really important topic as this world transitions to something quite a bit different, but with obviously a lot of the ethos from the past that's moved into this new spans of technology. So thank you again for being part of this. Thank you, David, for your wonderful presentation. And by the way, if people want to show up for another presentation, John Walensky is coming in on October 22nd. We have a number of speakers coming in, and you may be interested in John's take on some of this as well. Thanks again. The University of Regina thanks you all, and take care.